guys, let's get it done and dusted. Right here, right now. Alright, today, what are we talking about? We're going to talk about types of forces. By the end of this lesson, we should be able to tell the force or forces at play in a given scenario. Let's get right into it. Now, forces are generally grouped into two. We've got the contact forces and the non-contact forces. The names speak for themselves, right? What is the contact force? The objects experiencing the force must be in contact. Alright, a typical example is your frictional force. Contact force comes into play only when the object experiencing the force is in physical contact with the source of the force. Then you have the non-contact forces. In the case of non-contact forces, the objects don't necessarily have to be in contact in order to experience the force. Alright? That's right. This is because there's a force field around at least one of the objects. A typical example is a magnetic force. Another example of a non-contact force is gravitational force. It is the force of attraction between any two masses in the universe. Hence, it exists on other planets, on stars, on the moon or other moons. Here on Earth, our gravitational force is exerted upon us by the Earth. Alright? Now, when you're in contact with the Earth, you are being pulled by gravitational force. But you don't necessarily have to be in contact with the Earth to experience the gravitational force. You try to move away, it draws you back. You move away, it draws you back. Okay? So, gravitational force is a typical example of a non-contact force. Even if you are not in touch with the Earth, it can still pull you back. Now, let's demonstrate contact forces and non-contact forces. Magnetic force is the force between magnets and magnetic materials. I've got paper clips here made from steel. I've got a compass here. This is steel and this is brass. See what happens when we get the magnet closer to the compass. The compass needle moves. Let's take it back. Let's get closer again. Closer. There's actually a force between the compass and this magnet. The magnet and the compass are not in contact, but there is a force on the needle. The compass needle moves. That is, it experiences a force without actually touching the magnet. Magnetic force is an example of a non-contact force. Let's get the magnet closer to the paper clips. Closer, closer. Brass is an example of a non-magnetic material. Hence, it experiences no force from the bar magnet. Steel is magnetic. Hence, there's a force of attraction between the magnet and the steel. Electrostatic force is the force between charged objects. It could be attractive or repulsive. Let's tear up some pieces of papers from an old newspaper. Here's a plastic rod. I am going to charge this plastic rod by friction. by rubbing it with a cloth. See what happens. Let's charge it one more time by rubbing it. See what happens. This force is called an electrostatic force. The papers jump at the charged rod. Another example of a non-contact force is gravitational force. Gravitational force is the force which pulls us towards the center of the earth. It is the same force which keeps the earth revolving around the sun. Let go and it drops. I'm not throwing. Okay? I'm not throwing. I just let go and it falls. This is the model of the earth. The earth doesn't stand straight. It is tilted on its axis, round about 23.5 degrees. Let's take 3 people standing on the surface of the earth. The first one in Africa, the second person somewhere in Russia, and the third person in Brazil. These 3 people do not fall off the earth because of the force of gravity which tends to pull things towards the center of the earth. Hence, this person doesn't fall off the earth because it's being attracted by force of gravity. This other person doesn't fall off the earth because he's also being attracted to the earth by the force of gravity. And this person also doesn't fall off the earth because he's being attracted towards the earth by the force of gravity. Gravity is the same force which will attract you onto the surface of the moon. Just that the value of the force of gravity on the moon is different from the value on Earth. Let's talk about friction. I've got 2 surfaces here, a white one and a brown one. They both made from wood. Let's leave these 2 masses to slide down these inclined planes. What do you notice? What do you notice? I am not pushing these masses, I'm just leaving them to fall. Mass A actually travels slower than mass B. Why? It's because of friction. And what is friction? Why mass A moves slowly is because there's a force which is opposing its motion. And that force is bigger as compared to this one. Alright? That force which opposes the motion of an object is called friction. Friction is a contact force because the 2 objects must be in contact. The smoother the surface is, the less friction we have. The rougher the surface, the more friction we have. Here's a piece of cork dropped in water. This piece of cork floats in water because it is less denser than water. Alright? An object that is much denser than water will be this brass. This brass is more denser than water, so it sinks in water. Alright? However, this piece of cork floats in water because it is less denser than water. It floats in water, all right. I'm happy with that. But then, what about when I try to push it down? When I try to push this cork down, it bounces back up. I do agree that this is less dense than water. I do agree. Therefore, it floats on water. Yes, that's fine. But how about when I try to push it down? Okay? When I push it down, I have applied a force to push it down. Alright? Now, this cork should remain down there if there's no force acting on it. But here's the case, the cork pushes right back up. It is due to a force called upthrust. So you agree with me that this object experiences a force, a push force from the water, and that is called the upthrust. Upthrust is the upward force exerted by a liquid or a gas on an object floating in it. Upthrust is also called buoyant force. The brass also experiences an upthrust, but is overcome by its weight. Let's assume this object is not moving. It's just sitting in the water. If the object is just floating in the water, it experiences only upthrust. But when it starts moving through the water, it will experience upthrust and water resistance at the same time. Upthrust is the upward force exerted by a fluid on an object floating in it. Water resistance is caused by the water molecules colliding with the moving object. Remember, the upthrust is the upward force that the water exerts on the object. And water resistance is the force that the object experiences when moving through water. How would you define air resistance? Here's an object. Let's take this as air. When this object tries to move through air, see, it bends because the air exerts a force on it. Okay? Air resistance is brought about because the air molecules collide with the surface of the object. Now take a look at this rope. I'm trying to push it with my finger, but this rope doesn't apply any force to my finger. Alright? There is no tension in it. Why there's no tension in it is because there's no load attached to it, or there's no weight attached to it. Let's attach some weight to this rope. Immediately, there's a force generated in this rope, and my finger experiences a force. The force generated in a string, because there's a load attached to it, is called tension. There must be a load attached to the rope in order to get that force in the rope. So tension is the force in any rope, wire, or string with a weight or a load attached to it. Now guys, let me explain the concept of weight. But it will have to wait. No, I'm just kidding, right? Yeah, but really, it will have to wait. It will have to wait, okay? So let's put weight aside. Let's understand a couple of things before we come back to weight, okay? Beautiful. Now, let me start from mass. Mass is amount of matter. Now, let's ignore the bottle. The amount of water here is called the mass of water. This amount of water or mass doesn't change. I can take this bottle of water to the moon. It will still remain, the quantity of water in it will still remain the same. I can take this bottle of water, travel with this bottle of water to, let's say, Accra. The quantity of water in it will still remain. So mass doesn't change. Mass remains constant. Whether you travel from one planet to another, the amount of substance in it, the quantity will remain the same. Alright? We measure mass using electronic balance. Now the mass of water here is 0.4 kg. Mass is measured in kilograms. Are we clear with mass? Can we move on? Now that we understand mass and we understand gravity, we now move to the concept of weight. When gravity acts on a mass, the result is weight. Now you wait a minute. I got you right. I got you right. So in order for us to have weight, we must have a mass being acted upon by gravity. So mass is merely the amount of substance or the amount of matter. Weight, on the other hand, is gravity acting on the mass. Alright? So weight is a force because the gravity pushes the mass down, and remember, a force is a push or a pull. Weight results from gravity, which is a non-contact force. An aeroplane in the air has weight even though it is not in contact with the ground. So weight is a non-contact force. Quiz time! I love those quizzes. Are you ready for the quiz? I will mention the force. You've got one duty to tell me if it's a contact force or a non-contact force. Are you ready? Let's get into it. The first one is tension, a contact force or a non-contact force. You're right. Tension is a contact force. The second one is magnetic force. Is it a contact force or a non-contact force? You are right. Magnetic force is a non-contact force. The next one is upthrust. Is upthrust a contact force or a non-contact force? You are right. Upthrust is a contact force. The next one is electrostatic force. Is it a contact force or a non-contact force? Yes, I can hear you. Electrostatic force is a non-contact force. Gravitational force, the force due to gravity, the force which pushes things towards the center of the earth, even on the moon. Is it a contact force or a non-contact force? Huh? You are right. Gravitational force is a non-contact force. The next one is water resistance. Is it a contact force or a non-contact force? You are right. Water resistance is a contact force. The next one is air resistance. Obvious, right? Contact force. Okay. I love this one. I love this one, you know. There's a friction. Is friction a contact force or a non-contact force? Friction is a contact force. Give yourself a round of applause. No, not yet, not yet. Forces on a car when it is not yet moving. Can you name the first force? Weight. Weight. Can you name the second force? As this car sits on this road, the road is going to push it up. The second force is the contact force from the road. You can call it the reaction force or the normal force. Alright. Is there frictional force here? That will be static friction. Okay? Let's not go into that now. Now when this car starts to move, new forces will be added. Engine pushes the car with a thrust. So there's a thrust force from the engine. Now, if this car starts moving, the next force that comes to play is what? Is your air resistance. This car moves in that direction, the air resistance opposes it. That's with the car. Come on. Now, let's assume the engines are on. Now, this aeroplane is just flying in the air. Oh, come on. I feel tired, holding it. Could it be because it's got weight? Oh yeah! So the first force from this aeroplane is the weight. Alright? Is the weight. But I'm pushing it. What force could it be? That would be the lift force. Lift force. So we got two already. The weight and the lift force. Alright? Now, this aeroplane is moving forward. Or maybe it's reversing. We found the weight, the lift force. The next force going forward would be what? From the engines, okay? Will be what? Will be the thrust. High five. High five, high five. That will be the thrust moving it forward. And if this aeroplane is moving forward, what other force will come into place here? Air resistance. You are right. You're right once again. You're a genius. You're right. Air resistance in that direction. Okay, beautiful. I think that's about it. You can also refer to air resistance as friction in air and water resistance as friction in water. Air resistance and water resistance are types of drag. Now let's see the forces on a boat. Are you ready? There is a boat. The first force pushing down will be what? Weight. Beautiful. Wait a minute. Not that kind of weight, okay? Now, assuming this boat is not moving, it's just floating on the water. The water will exert a force, a push force upwards. What is the name of that force? I can't hear you. Upthrust. Push force up. What is that force? Did you say thrust or upthrust? Okay, that would be upthrust. You're right, upthrust. Whilst it's not yet moving, there's no water resistance. When this boat actually moves in the water, so when the boat starts moving, okay, with the thrust force, the force which pushes the boat back will be water resistance, experience water resistance. Alright, it's done and dusted, right? It's done and dusted right here. Well, I hope you liked the video. But anyway, if you didn't like the video, I liked it. Once again, I'm out of here. I'm out of here. I'm out of here. Yeah, I wanna know. Yeah, you tell me. Shall we take a break? What do you think? No break for me, no break. All right, okay, no break. All right. Okay. No, I want to work. Can we have some drinks? No drinks? Oh, okay, that's fine. I must finish the job first. Okay, that's fine. I'm going to finish the job. Okay. We're almost there, guys. We're almost there. I need my drink. We're almost there. All right. Let's examine some forces. It's got no engines here. Can you imagine? Oh, come on. No engines? Oh, come on. Let me get the engine. Alright, I'm coming back. I'll be right back with the engine. Okay, I found the engines. Alright, I found the engines. Just try to put them back. Alright. Oh, come on. We need an engineer. Hello, guys. Can we have an engineer in here? We need an engineer here. Come on. So, alright. Now, let's assume the engines are on. Now, this aeroplane is just flying in the thing. Mass is the amount Alright guys, let's be friends, okay? Like the video, subscribe to the channel, and share. Feel free to share it, alright? You don't pay anything for sharing the video. Guys, once again, I'm out of here. I'm out of here. I'm out of here. I'm out of here.